Computing probabilities. Let's look at the first scenario. We're going to be looking at the joint probability of two events. Now, if the two events, A and B in this case, are independent, then we can find the joint probability, in other words, the probability of both of them occurring together, as the product of their separate probabilities. Let's illustrate with an example. Suppose the probability that a student is female is 52%, so this would be event A. And at the same time, the probability that the student is using a pen as opposed to pencil would be 74%. And this would be event B. Now, what strikes out in this illustration? So whether the student is male or female, or whether the student is using pen or pencil, these two are completely independent events. So if we're asked, what is the probability that a student is female and using a pen, and that's what joint probability means, so the probability of both of them occurring at the same time, then we would just multiply the two probabilities together. So there it is right there. So there's that 52% for event A, 74% for event B. So the joint probability would be 38.48%. And to interpret that, there's a 38.48% probability that you'll see a student who's female and using a pen at the same time. Now let's look at the second scenario. Here we want to find the probability that at least one event will occur. Let's look at an example. Suppose that we have some potential merger deals. The probability of merger A going through is 35%. Probability of merger B going through is 28%. However, the joint, so that's a joint probability, the probability that both merger A and B will go through is 12%. Now, one thing I want to point out here, because a lot of candidates will sort of utilize this and then say, you know what, the product of these two is not necessarily 12%. That may be true, but you have to remember, what's the only condition in which this would hold, where you would multiply the two probabilities together? If the events are independent. So we don't know in this case if the events are independent or not. So just something to keep in mind. So anyways, let's work with these figures. And what we're asked to compute is the probability of either A or B going through. In other words, probability of A or B or both mergers occurring. Now tip, if the outcomes are not mutually exclusive, in other words, both deals may occur simultaneously, then the framework we would use would be the Venn diagram. Now, how do we know that these events are not mutually exclusive? Because it's right there. They're telling us that there is a chance that both deals may go through at the same time. So let's see how we can answer this question. In other words, we want to know the probability at least one of these deals going through, if not both going through. And here's the way the Venn diagram works. So we use Venn diagram when there's an overlap. And we know there's an overlap because there's a chance that both A and B will occur at the same time. So what we're going to do is, in one of the circles, we're going to have event A. So the probability of event A is 35%. And the other circle, we're going to have event B, and the probability of that is 28%. And then right in between here, we're told that there's a 12% probability that both will occur. Now, if you look at the question again, it says, what's the probability that at least one will go through? So if you read it carefully, it says A or B or both. Just give me the probability that at least one deal will go through. So all we have to do is just find the length of this line, because if the event falls anywhere on this line over here, it means either A or B or both have gone through. So how do we find the length of that line? Well, we've got the three segments. We just got to piece it together. So starting from here, going there, that's your 35. But then you can see there's duplication. So what we want to do is we want to so basically follow the lines I'm drawing, come like this, right? So subtract the 12, and then you're back to here, and then you complete the rest of the journey by adding 0.28. So if you add up all those segments, you get 51%. And let's have a look at the summary here. The probability that both deals will go through is 12%. And I'm just putting this here so we don't mix up all these different interpretations. However, the probability that at least one deal will go through is 51%. So please make sure we distinguish between the two types of events that we're being asked to find the probabilities for. Now in case 3, we're asked to find the joint probability of multiple independent events. Well, you know what? It's very similar to just having 2 independent events. It's the same framework. We just multiply the probability of all those events together because they are all independent. So let's look at an example. Suppose a manager has 10,000 stocks to choose from. Therefore, the manager sets up 3 independent screens, and that's how investment managers do it, ladies and gentlemen. So how do we create a short list out of 10,000 stocks? We create some screens, like what are you looking for, right? Like high PE stocks, low PE stocks, or sales growth, or whatever, right? So here are the 3 screens. Now, the probability that the stock will meet one of these screens is as follows. So the probability of a stock meeting screen A is 18, 5% probability of meeting screen B, and 30% probability of meeting screen C. So, but the thing is, the manager wants to pick stocks that meet all the screens simultaneously. So therefore, probability that a stock meets all the screens is just a product of these independent events. And this would be equal to 0.27%. So again, ladies and gentlemen, do you see the difference, the interpretation? There's 10,000 stocks. Out of the 10,000 stocks, 18% can meet screen A, 5% can meet screen B, and 30% of that same 10,000 stocks can meet screen C. But the question says, well, what out of the 10,000 stocks, what's the probability that the stock will meet all the screens simultaneously? And that would be over here, 0.27%. And on the exam, they may ask you to actually translate that to number of stocks. No problem. So only 0.27% of all eligible stocks, which works out to 27 stocks out of the 10,000 that would meet all of the manager's criteria.